Hi everyone. I've been playing around with the Move smart contract language for some fun, and I recently spent some time working on the Starlight protocol, which is a payment channel protocol for the Stellar network. And so I wanted to see what it would be like to create a similar style payment channel in Move. So I've got a few contracts here that I've written that all come together for this. So we've got the coin contract, which contains just all of the basic logic for my coin. Things like accounts owning coins, trusting coins, and paying each other. And then I've got the fun coin contract, which provides an identity to my coin, so I could have multiple different types of coins all using this coin contract. And then we've got the time contract, which we're going to use to mock just some fake time, which just makes easier testing. And then finally, the channel contract, which is the actual channel that the two accounts are going to use. So let's get into it. Let's run this. Let's run this demo. So I've got a series of scripts that are just going to run commands, just real basic things like initializing coins, times, trusting the coin, minting some coin, and then doing a quick payment. We'll run those first, and we'll just make sure we've got some basic mechanics working. So, oh yeah, let's actually just clear the environment real quick. So we've got a clean environment, clean. We're using the move sandbox, so it just stores the state of the chain in the storage directory. And we'll publish our contract. So all our contracts, all our modules are published, and we can start initializing them. So we initialize the coin and the time contracts. We will have accounts 3 and 4. They're going to be the two accounts that are actually transacting with each other. They're going to trust the coin in the similar way that accounts trust assets on the Stellar network. And let's mint some coins. So account 2 is sort of like the super user in our test, and then accounts 3 and 4 are the regular users, and they're both going to get 100 units of these coins minted. And if we have a quick look at using the move sandbox view command, what's actually stored for these accounts, we can see, there we go, we can see account 3 has 100 units of the coin that were minted to it. Account 4 has the same. Let's run a quick payment just to make sure that we've got some basic payment mechanics here. So we can see, great, 3 has 98, 4 has 102, because we did a payment from 3 to 4 of a value of 2 units of payments. Okay, so we've got some basic mechanics going here. Let's initialize the payment channel. So we're going to initialize the payment channel with 3 being the owner of the channel, so they're going to sign the transaction or the script, and 4 is going to be the other participant in the channel. And if we have a look again at using the sandbox view command, we should be able to see this set up pretty clearly. The channel has a few things that it stores, one of them being the config. So we have these 2 participants, I and R, 3 and 4. Now 3 has joined the channel because they created it, but 4 also needs to choose to join the channel. So 4 is going to run a transaction. It looks basically like the parameters are reversed. 4 is the signer because they're the one in control of this transaction, this operation, and 3 is the owner of the channel. So we're going to see 3 show up a lot in a lot of the commands because we're just referencing that 3 is the owner of the channel, so that's where the script and the contract need to go to find where the core data is stored. Okay, great. So 4 has now joined the channel as well. And if we have again a look at this with the sandbox view command, at what's actually being stored for these two users, they both have this membership state being stored. And this membership state is really lightweight. It's just storing an amount that they've locked up in the channel. So at the moment, we haven't deposited any money for either user. And so their memberships both have locked up no amount of this coin. So let's go ahead and run a deposit command for both of them. They're both going to deposit 50. So you can see the signers, respectively 3 and 4. The first argument is then the owner of the channel 3. The next argument after that is the address that we're depositing for. So 3 is depositing for themselves, 3, and 4 is depositing for 4, and they're both going to deposit 50. So now if we go back and have a look at what's locked up, we can see 3 has 50 locked up, 4 has got 50 locked up, and then if we also go back and have a look at what 3 and 4 have on chain, we can see, okay, 3 originally had 98 coin after we did that payment of 2, and we've taken 50 out of their balance and we've locked it up in the channel. So if 3 wanted to do some payments right now, they wouldn't be able to spend the full 98 because they've locked 50 in the channel, which is exactly where we want to happen. Now, so the way the payment channels work is that both participants can sign these operations off-chain, agreeing to some new settlement amount, which will be the final payment that actually occurs on-chain. So if you imagine if 3 pays for 10 units of the coin, they would have an agreement which was 3 pays for 10. And then if 4 wanted to pay 3 15, we would update the payment to be 4 pays 3 5, because 3 had already paid 4 10, and for 4 to pay 3 15, what we need to settle that agreement, those two agreements, is just a payment of $5. And so that's basically how the payment channel will work. And what we're going to do is we're going to assume that at least 120 payments have occurred. That's what this argument here is here. This is the sequence number of this agreement. And at this point in time, at a payment 120, the final settlement was for 3 to pay 4, an amount of 10. And then this 2 on the end is the delay of time that needs to pass. So 2 units of time needs to pass before the channel will close. And within that period of time between when this operation is executed on chain and that 2 finishes is the period of time that either participant has to dispute by submitting a newer operation, like a newer, an agreement that has a sequence number higher than 120. So let's submit this. So we'll start the close process with the agreement that was number 120. And let's go back and have a look at some of the data that's being stored on chain. So the channel stores the close state. And we can see here the close state, once the close has begun, is sequence 120, which matches the close that we started. We can see that the sequence time is 1. So at time unit of 1, this occurred. The payer is from 3 to 4, value of 10, just like what we ran our command here, and delay is 2 because that's the period of time where we have to wait before we can withdraw. So let's assume that this gets run, and let's say 4 wants to get their funds straight away. Maybe 4 submits this on chain and they really want to get at the funds this close statement says that they're due. So we can run that, and I'm actually missing an argument here by the looks of it. Can run that, and we can see we got error code 4. Okay, so that's really interesting. Let's have a look at what error code 4 is. Error code 4 is not closed. Okay, well that makes sense. The channel's not closed because we're closing, we haven't closed yet because we're still in this delay period of 2 units of time. So let's think for a second. Maybe okay, so maybe something, maybe this isn't actually the latest agreement. So we said we have that 2 units of time to dispute. let's pretend that there is a dispute. There was actually more payments, 136 payments. And so 3 sees this. 3 sees that 4 submitted, that 3 pays 4 10, and sees, oh, hey, that's out of date. I'm actually owed some money from 4. And the lease agreement is actually for 4 to pay 3 an amount of, let's say, 8. So let's run that. And we'll see that that works because this is a newer agreement. The contract knows that both participants signed this new agreement, so it must be valid. And so we can see here now that the close date has been updated. The amount that's available to be withdrawn is 8 as opposed to 10. But we still have now we have another 2 units of time. So time is currently at 3, and we need to wait another 2 units of time before we can get access to it. So let's move time forward to 5. So let's just pretend time's moved forward now, and see if we can actually withdraw at this point in time. Great. So it looks like 3 was able to withdraw from the channel that's owned by 3. And let's see if 4 can also withdraw from the channel that was owned by 4. Let's go back and have a look at what the state of the channel is. So we can see the state is still here, but the amount has been withdrawn. So there's no value here anymore of Funcoin. And let's use the sandbox view command to have a look at what the balances of 3 and 4 are. Great. So the value of 3 is now holding 106 coins, which is great because it had 98 at the very beginning, and then it was eventually, the settlement was for it to receive 8. So 106 is the correct amount. And let's see, 4, yes, so 4 has spent $8 of its 102, or 8 Funcoin of its 102, and so now it's down to 94. So it works. Great.